Now we're going to do, we're still doing grade 10 trigonometry, and this is finding sides and angles using a trigonometric ratio. Exercise 5. The question says that round answers off to one decimal place in this exercise. And question A says calculate the length of PQ in the triangle PQR. Then when I look at this question here, one angle and one side is enough information for us to find the side PQ or any side of the right angle triangle or any other angle. Like in this case, for instance, I look at this angle. I look at this angle 42 degrees. How can I compare this angle and this side PQ? Okay, and we say that you can see that angle, the 42 degrees angle here is adjacent to the angle PQ. I mean to the side PQ. Okay, this side is adjacent to PQ. Okay, and it is opposite QR. But now I'm not looking for QR. The question says we need to find PQ. So because it is adjacent to PQ, we know the formula says that cos of the angle, the ratio says that cos of the angle, okay, is adjacent side over hypotenuse. Okay, sometimes they say x over r, where x is the adjacent side and r is the hypotenuse. Now, I will say here in the calculation, I will say that just move this over here. And they are there also. All right. Now, I can find now. I will say cos of 42 degrees. Okay, will be equal to adjacent side, which is PQ, which is the ratio I'm looking for, over hypotenuse, which is 3. Okay, now understand that there is an invisible denominator over here. We can solve this by cross multiplication. We can do that 1 times PQ and then cos 42 degrees times 3. So this will be that PQ will be equal to, the constant must come before the ratio. So we have 3 cos of 42 degrees. Now we can over here use a calculator. Can use my calculator over here. We can just write the 3 and then cos of 42 degrees. Okay, close that and then hit equal. Then we can get the side PQ is equal to 2,20. Okay, let's say round off to how many decimal to 1 decimal place. Okay, 1 decimal place means we need to look at the second decimal value, which is 2. Now, because the second decimal value 2, okay, is lesser than 5, we will just drop the remaining digits, including 2, these 2. So the answer will be 2. So it will be 2 times 2. So the length PQ here is just 2.2. Same, we can also use to calculate B. The question B says calculate the length of AB and then calculate the length of BC. So we have one angle given, 67 degrees, and one side given. It is enough for us to calculate any other side or any other angle. Excuse me. Now B1, I look at AB. Now how is AB with towards 67 degrees? Okay, how I need to compare the two. I'll say that this angle here is opposite. Okay, it is opposite. It is opposite AB. Now, what we do know is that sine of the angle theta, for instance, in angle theta, is equal to the opposite side over hypotenuse. sometimes the opposite side is referred to y, and the hypotenuse to r. Okay. Now, I just feel like I should have brought it next to. Just say please rewrite it over here. So sine of the angle will be opposite side over hypotenuse. Sometimes it is in that opposite, which is referred to y, the hypotenuse referred to r. Then we can solve the problem. B1, we're looking for AB. I will say sine of 67 degrees will be equal to, the opposite side here is AB over the hypotenuse is given 5.6. Okay, so we understand that there is an invisible denominator here, which is 1, and then we can solve this by cross multiplication. We do 1 times AB, okay, and then sine 67 degrees times 5.6, and then that makes AB will be equal to 5.6 multiplied by sine 67 degrees. Okay, and then we can use our calculator. We do like 5.6 multiplied by sine of 67 degrees. Okay, and then we hit equal. This is equal to 5.15. Okay, to one decimal place, I look at the second decimal value, which is 5. So I will increase 1 by 1 unit. So that makes AB will be 5.2 units. Okay. Those are sides. They're not expressed in degrees. They're expressed into units like centimeters, meters, and etc. Question B2 says calculate length BC. So we're looking for this length here. Okay. Now, we can solve this in 2 different ways. Look at this carefully. This angle is adjacent to the side BC. So we can use cos. Okay, we can say cos of the angle theta is equal to opposite side, no, sorry, adjacent side over hypotenuse, which is sometimes adjacent side referred to x and hypotenuse refers to r. So in this case, we can say that cos of 67 degrees, okay, equal to adjacent side, which is BC, over hypotenuse, which is 5.6. Okay, and then over here, we have a denominator, which is 1, and then we can cross multiply. We do 1 times BC, and then all this times 5.6, and then this will make what? BC will be equal to 5.6 multiplied by cos of 67 degrees. And then that makes BC will be equal to, over here, we can just say cos of 67 degrees, and then that makes 2 points, okay? To one decimal place, we look at the second decimal value, which is 8. And then the fact that 8 is more than 5, we increase 1 by 1 unit, that makes 2.2 units, okay? This is one way of solving that. But we can also use the 10th formula in this case, because the 10th formula, 10 of theta, is given by opposite side over adjacent side, okay? Which is sometimes opposite is y, adjacent is x. I said that because we did calculate AB in the previous question. So AB, we found that AB was 5.2. So we could also use this formula by saying that 10 of 57 degrees will be equal to opposite side, opposite. When I say opposite side, I say opposite it's with reference of the angle. Okay, it's opposite side to the angle is 57 degrees. Sorry, 67 degrees. Excuse me. I don't know where I was. I meant 67 degrees here. The opposite side is 5.2. And then the hypotenuse is what we're looking for, is BC. So over here we have like an invisible denominator. Here we can cross multiply again. We can do this times that, and then all this times that. That would make what? BC equal to, no, not BC equal to, but BC multiplied by 10 over 67 degrees equal to 52. Not 52, but 5.2, excuse me. And then we can divide by 10, 62. Divide by 10, 62. 67, I mean. And then that will make PC equal to, we can use the calculator over here. 5.2 over, sorry for the network, it's okay. 1067, and then it's equal to, you see, 2.2. 2.2 as we get 2.2 here. We also have 2.2 there. Okay. Also have like question C here. The question says that after the size of the angle theta, theta is given there. Now over here, I'm going to look at my triangle here. I have like two given sides. So sides, one side is 9 and the other is 7. So what I'm looking for is this angle theta, and then this side is given, as I said, and that one. So the formula that I can use here is the tan formula, because I know that tan theta is equal to opposite side over, okay, over adjacent. So in this case, I look at the opposite side to the angle theta is 7, and the opposite side is 7, and the adjacent side is 9. So over here we can say that 10 of theta will be equal to opposite, which is 7 over 9. Okay. And then say if we need to find theta and the angle down, we can say that the angle theta will be equal to 10 minus 1 of 7 over 9. Now in the calculator we say to get 10 minus 1, press the shift button. Okay. Careful here, the minus 1 here, as we did in the previous videos, that is not 10 to the power of negative 1. It simply means the inverse. Okay, it simply means helps us to find what angle is here. So we press shift first, okay, and then we press the 10 button. Then we can write there 7 over 9. 7 over 9. And then hit equal button. So this is equal to 37.87. So they say to one decimal place, it's going to be 0.9. Makes theta be equal to 37.9 degrees. That's the angle of theta. And now the question says, question C2, that was C1. C1. Now question C2 says, calculate the length of AC. So this length here, AC. We can calculate this by using the Pythagorean theorem. Remember, it says that C squared, okay, C squared is the hypotenuse, the long side of the rectangle triangle. It's going to be A squared plus B squared, okay? But sometimes they write it like R squared equal to, okay, sometimes they write it like R squared equal to X squared plus Y squared, see the same thing. Or sometimes we write it like H squared equal to A squared, adjacent side squared plus O squared. So all these three formulas talk about the same thing. Now, we can calculate AC in this case, which is our c squared, it is our h squared, or it is our r squared. You can say, now that's over here. So we can say AC squared will be equal to 9 squared plus 7 squared. Okay, so that means AC squared equal to 9 squared is 81, and then 7 squared is and now we can do AC squared will be equal to 130. Now we can calculate AC then, which is possible if we square root both sides. We can square root here, square root there, and then we can use a calculator. 81, let's say 81 plus 81 plus 49 plus 30, and then square root of 130 is equal to, we press S2 there, and that's 11.4. So AC will be equal to 11.4. Now we can also calculate, do question D. The question says calculate the size of the angle alpha and then the size of the angle theta. So we have like the hypotenuse is given, and then also this side is given. So if I need to find alpha, I look at this angle alpha here. Okay, so this angle alpha, of course, is opposite to the side RQ, but RQ is unknown, so I can't really use this. I can't really use the sign formula, because sign says sine of the angle equal to opposite of hypotenuse. But alpha is adjacent to 6, so I can use the cos formula. Okay, did you say that cos of an angle is equal to? Let me just change the angle here. The formula will be like, I can take any angle like gamma. Usually use Greek letters, okay, to identify angles. So those alpha, theta you see here, they are from the Greek alphabet. There are about 20 letters in the Greek alphabet. Alpha, beta, gamma, sigma, and even pi is one of the pi that we use in math. This symbol is also one of the Greek alphabet. So I'm going to use beta then here. This angle here, that's the formula. Cos of beta will be equal to, this is the formula, okay? It's going to be adjacent over hypotenuse, okay? Sometimes x over r. All right. To substitute here, I'm going to say D1, I'm going to say that cos of alpha will be equal to adjacent, which is 6, over hypotenuse, which is 10, which means that cos alpha equal to 0.6, 6 over 10. Then we can use the inverse function in the calculator here to find alpha. So we press shift button, the button here shifts, and then we press the cos button that tells us the inverse. So calculate the value of the angle, 0.6. Now we can say therefore alpha will be equal to 53 degrees. Okay, it was 53.1 degree. Okay. We can also do D2. Let's look at D2. Let's say angle of the size theta. Theta is over here. When I look at theta here, it is opposite, okay, to 6. So because opposite here, I can use the sine formula. And write the formula here, and I say here sine of the formula. It can be lambda, it can be gamma. Sine of gamma is equal to opposite over hypotenuse. which is sometimes y over r, okay? So, d2 will be sine of theta here will be equal to opposite over hypotenuse, which is 0.6. Now to get theta, then theta will be, we will do we press shift button, okay, sine, and then 0.6. We calculate and then hit equal, that makes 36.9 because we want to one decimal place, so 36.9 degrees. So that's the value of theta. Okay. Now we can also do other questions like let's see question E. Here the question says calculate the length of AC. Okay, so I look at AC. We have the angle here. Okay, angle is this. It's not to the hypotenuse, but there. This angle is adjacent to BC, which is equal to 8. So we use because it's adjacent, we're going to use the sine formula. Okay, so the question says sine of theta. The formula says sine of theta equal to adjacent side over hypotenuse. So see adjacent over hypotenuse and times x over r. Now the values. Okay, we say that sine of 67 degrees will be equal to adjacent, which is 8, over hypotenuse, which is just AC. Okay. It's okay. We can solve this by cross multiplication. One day, and then we will do times 67 degrees times AC, and then 1 times 8. So that makes AC times sine 67 degrees equal to 8. Now, to get the value of AC, you can divide both sides by sine 67 degrees. Okay, and then that will make AC will be equal to, you can use a calculator, 8 over sine of 67 degrees, and then it's equal. AC will be 8.7. Okay, 8.7. I say 8.7 because we need to round to the first decimal place, as the question indicates, and then look at the second decimal value, which is 9, and then therefore we must increase 6 by 1 unit. Okay, that makes 8.7 units. Okay. The next question will be now the question here says in the diagram, BD is perpendicular to AC. Using the information provided, calculate the length AC. So I'm looking at the diagram given here. You can see that D here is perpendicular to AC. And now, we are looking for the length of AC. How can we do that? Now, BD is given to be 3.5 meters. Okay, so we can calculate. We notice that we have angle 48 degrees here. This angle is opposite to BD. Same also with the 42 degrees is also opposite to BD. Now, we can use to find no, not the side formula, but the cos formula to find the adjacent side. Because if we know BA and we also know BC, we can find AC. Okay, so now we can use the cos formula that says cos of the angle theta is equal to the opposite side. No. Adjacent side even the doesn't work. Doesn't really help us. Now we can use 10 instead. Because we have like this side, the vertical and the horizontal, we can use 10. Better to stand here. We can just say 10 of the angle theta is given by opposite side over adjacent. Yes. Sometimes y over x. So find we can say 10 of 48 degrees will be equal to opposite side, which is 3.5 over AB. Okay, AB or BA is something. Now we can cross multiply here. We can multiply this by that and then that by that. So that makes AB times 10 of 48 degrees equal to 3.5. Now to get the value of AB, we divide by 10 48 over 10 48. And then that makes AB equal to, we can use our calculator. 3.5 over 10 48. And then hit equal, that makes 3.2. So that means rounded to the second decimal, to the first decimal place. So AB is like 3.2. Now we can use the same formula to find BC. Okay. That's gonna be like 10 of 42 degrees. Okay, equal to opposite side, which is 3.5 over adjacent side, which is BC. And then cross multiplication equals to an invisible 1 over here. Do 10 42 times BC and then 1 times 3.5. That will make what BC 10 42 equal to 3.5. Now to get the value of BC, we divide here by 10 42. Then also by 10 42. And then let's use our calculator. So it's going to be 10 42. And then this is equal to 3.9. So this will be BC equal to 3.9 rounded. Okay, this is rounded to the second decimal, to the first decimal place. Okay. Therefore, AC, which is equal to AB, or maybe AB plus BC. Sometimes you want to read it as a CB plus BA. It's the same thing, okay? That will be equal to 3.9 plus 3.2, which is 7.1. 7.1 meters here. So it's expressed into meters here. 7.1 meters. Okay. Now, we're gonna do question. The next question is G. G. Okay. The question says that in the triangle ABC, CD is perpendicular to AB, and then we have angle A equal to theta, angle B equal to 40 degrees, AB equal to 15 centimeters, and then DB equal to 60 centimeters. Calculate the size of the angle theta. Right. In this question, you notice that in the first triangle, we have like more information than we have in the second triangle. Over here, we have like an angle, and then the angle is given, and then also the side is given. Here, the angle is not given, just theta. Don't know the value of theta. Here, the angle is given like 40 degrees. Here, we don't know what theta is equal to, and then one side. So now we can use the information on the first triangle to find the missing side, okay, CD. So, and then we can find the angle, the value of the angle theta. Now let's do that. Over here, I look at the angle here is adjacent to 16 centimeters. And then it is also opposite to CD. Now, I can't use the cos formula here because cos will give me the hypotenuse instead. If I was looking for the hypotenuse then, but I need this side, so I can use tan formula. Tan of the angle is given by opposite over hypotenuse, okay? Excuse me, opposite over adjacent. Sometimes y over x. So that's 10 over 40 degrees will be equal to opposite, which is CD, over adjacent, which is 16, okay? And then we can cross multiply here, it's divisible one there. So that makes CD equal to 16 multiplied by 10 40 degrees. Okay, listen to me. Don't do 40 degrees times 16 degrees, okay? So okay, I could have write like this. But it's not accepted. You know, in case someone times the degree, the 40 degrees will be 16 here. So we don't do that way. Okay, so just 16 times 10 or 40 degrees. Now we will calculate what CD is equal to in the calculator. So we can do 16 multiplied by 10 over 40 degrees. And then this is equal to 13.4. 13.4. That's the length CD. Then we can use that information to find the missing angle here, the angle theta. Okay, using the same formula here. So we know that 10 over, this is 13.4. We know that 10 over the angle will be equal to 10 of theta will be equal to opposite over adjacent. So 13.4 over 15. Okay, and that means 10 over theta will be equal to 13.4 over 15, which is 67 over 75 plus SD. That makes 0.9. Okay, you have that to be the first decimal place. That makes 0.9. Now, I can get the value of theta. It's going to use the inverse formula. So we can do we press shift, okay, and then we press 10, and then we write there 0.9. Okay. And then this is equal to 41.98, so that makes 42 degrees. Because I want to round this to the second base, to the first decimal place. I look here, it's 9, it's 8. If I increase 9 by 1 unit, it's 9 here. I'm gonna make it 0. I will increase the integer, okay, 1 by 1 unit. That makes 42 degrees. Okay, that was question G. H. It says that using the information provided on the given diagram, calculate the length of BC. All right. We have the question here is question H. It says that using the information provided under the given diagram, calculate the length of BC. All right, when I look at BC, it's over here. What can we do here in this case? So maybe we should find, I need to find this length. Okay, so if I have at least one length and one angle, this one or that one, and one angle, then we can find BC. But it's going to be tough. I mean, longer for me to calculate this one, but rather calculate this length. To do that, first we're going to find what is this. Okay, from there we can calculate that, and then we can find this. Now let's see. Over here, in the first triangle here, look at, maybe I should highlight the triangles. In this triangle here in yellow, we have like one side is given, which is the longer side, the hypotenuse, because this is a 90-degree angle. It must also be 90 degrees, okay? So we have also one side given. No, one angle, this angle is 40 degrees. Or I'm saying 14 degrees. One side and do this way, okay. This way. So if I need to find this side, this one, I will, it's adjacent, this side is adjacent to this angle 14 degrees, so I can use the cos ratio. So cos of the angle, we do know it is adjacent over hypotenuse, okay? So we can then say that, okay, we can then say that cos of 14 degrees will be equal to adjacent side, which is 80, over hypotenuse, which is 70 millimeters. So there's an invisible one there, we can cross multiply, do 1 times 80, and then 70 times cos 14. So this would make like 80 will be equal to 70 multiplied by cos 14 degrees. So let's use our calculator. We do 70 multiplied by cos 14. That makes 67.9. To the first decimal place, meaning we will increase this 7 by 1 minute, that makes 68. So 80 will be equal to 68 degrees. Not degrees, sorry, millimeters. It's a length, okay? Length is always into units, like it's not in degrees. Then we got this length. Now I need to find this one also. Let's first see. The angle 36 degrees is also adjacent to this side. Okay, so I can use the sum formula, okay, to find okay, this will be the hypotenuse. Yeah, I can find this. I can use the sum formula. So this will be like the adjacent side will be 68. So it's gonna be like, it's gonna be cos of 36 degrees will be equal to 68 over the hypotenuse, which is the amount here. So we cross multiply again, because there's an invisible one there. So this makes like 1 times that, and then h times that. So this would be h times cos 36 degrees equal to 68 degrees. So to get the value of h, we'll divide both sides by cos 36 degrees. given by cos 36 degrees. So I don't know where I put the degrees here. There's no degrees there. Just 68 is the length. Now we can find what h is. H will be equal to 68, okay, over cos 36. And then it's equal 68 over cos 36 equal to what? 84.1. Okay, because we have to one decimal place, it makes 84.1. Now we find the hypotenuse. This is 84.1. Now we can find CD. Okay, therefore CB or BC will be let's just call it BC as what we should indicate. BC will be what? This angle is still this angle 20 degrees is adjacent now to AB, and then it is opposite to BC. And we will say, okay, this that we're looking for, we're going to use the sign now. The sign, we say sine of the angle theta is given by opposite side over hypotenuse. So over here, sine of 20 degrees will be equal to the opposite side, which is BC, over the hypotenuse, which we find here, 84.1 is hypotenuse. 84.1. Now, the distribution of 1 over here, and then we can cross multiply 1 times BC, and then 84.1 times 1 times sine 20. So that makes BC will be equal to 84.1 multiplied by sine of 20 degrees. Now we can use our calculator again. 84.1 multiplied by sine 20, and then hit equal. That makes BC equal to 28.8. Let's see again. I said 28.8 because we round to the first decimal place, so we will increase. This is 6, so we increase 7 by 1 unit, so that's 28.8 millimeters. Okay, millimeters. Good. Again, to do now, the next question is question 5. The question says, in the diagram, in the given diagram, the triangle ABC is a right angled at C. Okay. It is given that AC equal to 4 units, 10 of A equal to 3 over 2, and the angle A means an acute angle which is between 0 degrees and 90 degrees. Now the question says, determine the length of BC without solving the for A. Calculate the size of P, determine the length of AB. Right. Let's start with question 1. It says that determine the length of BC, and then the condition is given without solving A. Okay. When I look at A, it is this angle here. So we don't need to solve this angle. We need to determine BC. What we know from the questions, like 10 of the angle A is given is 3 over 2. Okay. And we also know that the 10 is given by 10 of the angle is given by opposite over adjacent. Okay. And here we also tell us that 10 of A equal to 3 over 2. So and then when I look at 3 over 2, they are like in the simplest form of the fraction. Yeah, it cannot be simpler than that. So this implies that 3 is the opposite side, and then 2 is the adjacent side. So this means this part is 3 units opposite to A, and then this is 2 units adjacent to A. Therefore, BC equal to 3 units. Okay. Now question 2 says calculate the length of angle B. So the angle we're looking for here now is this one. Is this one, angle B. Angle B, we can apply the same process, okay? Angle B is, we can use the 10. 10 of B. 10 of B, of the angle B here, will be opposite over adjacent. Opposite B is 2 units, and adjacent to B is 3 units. So this is going to be like 2 over 3. Simple as that. Okay, question 3 says what? Determine the length of AB. Okay, AB is the longer side of this triangle, meaning the hypotenuse of the triangle. So hypotenuse according to Pythagoras says that c squared equals to a squared plus b squared, or sometimes, as you say, if we want to use h squared, so the hypotenuse squared equals to adjacent side squared plus opposite side squared. Sometimes they write it like r squared equal to x squared plus y squared. So all these formulas, depending on the text you use, will tell the same thing. Okay, so I will say here AB then will be equal to 3 squared, AB squared actually, 3 squared plus 2 squared. So that means 9 plus 4, that means 13. But remember, we're not looking for AB squared, we're looking for AB. So AB then will be square root of 13. I guess square root of 13. Okay, the question says we need to simplify to one decimal place. So 13 is a set, so we can just say square root of 13, which is equal to 3.6. So AB equal to 3.6 units. Okay. Well, we have another question here, question 8. The question says that in the diagram, in the given diagram, the triangle ABC is right angled at C. Excuse me. Question J says that in the triangle PQR, QS is perpendicular to PR, QS equal to H, units PQ is equal to M units, QR is N units. Now question 1 says express sine P in terms of H and N. So sine P, the angle P is there. We do that sine, let me see question 1 here. We're looking for sine P in terms of H and N. We know that sine is given by opposite side over hypotenuse, okay? So I'll say sine of P, opposite P is H, and hypotenuse is N. This is expressed in terms of H and N, okay? Then question 2, express sine R in terms of H and N. Sine R, angle R is over here. So I'll say sine R will be, okay, here, the angle sine R will be equal to opposite H over hypotenuse, which is N. Okay, 3, hence show that M sine P equal to M sine R. M, this will be then, okay, let me write over here like that. M sine P equal to N sine r. Okay, so now previously we did find that sine p was given by h over m, and then sine r was given by h over n. Now we can simplify m and m here, and then n and n there, and then we have like h equal h, which is proven. Okay, true. Proven. Now question 4, I wrote it over here, says that now use the result in 3 to calculate the size of P if it is given that M is 40 centimeters, N is 30 centimeters, and R is 80 degrees. Right? So we'll do right here N sine P M sine P equal to M sine R. Okay, and then M is 40 centimeters now. Sine P will be equal to N, which is 30 centimeters. Sine R is 80 degrees. So we can move 40 degrees, divide both sides by 40 degrees. It's going to be like 30 sine 80 degrees divided by 40, not 40 degrees, but 40 centimeters, sorry. We divide by 40 here, divide by 40 there also. If you divide, it's going to be like 3/4. Let's just use a calculator. You can let's see calculator, it's going to be like 30 30 centimeters multiplied by sine of 80 degrees, okay, over 40 degrees, which is equal to 0.77, okay? So sine P is 0.7. Now we can find the value of P, the angle P. P will be equal to, if we use the inverse function, so we're going to press shift here, and then press sine, and then there we say 0.7, and then this is equal to 44.4. So 44.4 centimeters. That's it. Thank you.